Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 9-4 Extra Practice Number 1 solutions on algebraic limits of piecewise functions. For this one, we're trying to find the limit as x approaches -2 of this piecewise function. Since -2 is a border value, that means we have to consider the left and the right-sided limits at -2. So checking out the left side limit for -2, that involves plugging -2 into this first rule, this before -2 rule. So that's going to be -2 minus 2, which is really positive 2 minus 2, which is 0. Next, taking a look at this second rule here, because now we need to do the right-sided limit of -2. That's going to be -2 plus 6, which comes out to 4. Since these limits are not the same thing, that means the two-sided limit at -2 does not exist. On this problem, we're trying to find the limit as x approaches -3 of this piecewise function. Now, -3, as it happens, is the border value between these two rules. That means we have to look at the left and the right-sided limits at -3. So checking out as we approach -3 from the left side, that uses this first rule, this less than -3 rule here. So we've got -3 plugged into all of the x values in that first rule. So going through here and just using a little PEMDAS, we've got -3 squared is 9, but that's becoming negative because of that negative out there. So we have -9 plus 12 is going to be 3. Minus 4 gives us a grand total of -1. Next, limit as x approaches -3 from the right side. Now we're using this second rule here, the greater than -3 rule. So that's going to be -3 plus 2, which comes out to -1. Since we get -1 on both of these, the two-sided limit then is also going to be -1. On this piecewise function, we're trying to find the limit as x approaches -1. That's the border value between these two rules, so we have to look at the left and the right-sided limit to make sure those are actually going to be the same thing. So checking out the left-sided limit as we approach -1, that uses the less than -1 rule here. So that's going to be -1 squared minus 4 times -1 minus 4. So this is -1 plus 4, which is 3, minus 4 comes out to -1. Next, we check out the limit as x approaches -1 from the right side of f of x. That uses this greater than -1 rule. So we have 2 times -1 plus 4. That's -2 plus 4, which comes out to 2. Since the left and the right-sided limit are not the same thing, that means the two-sided limit as x approaches -1 does not exist. For this one, we want to find the limit as x approaches 3 of this piecewise function. Since 3 is a border value, we're going to plug it into both of these rules to find the left and the right-sided limits. So the left side limit as x approaches 3, we're going to use the less than 3 rule here. So that's going to be -3 squared plus 2 times 3 minus 1. So we have -9 plus 6, which is -3, minus 1 gives us -4 for that limit. And now to find the right-sided limit at 3, we're going to use this greater than 3 rule. So that's going to be 3 minus 1, which comes out to 2. Since these limits are not the same thing, since the left and the right don't agree, that means our two-sided limit does not exist. For this problem, we're trying to find the limit as x approaches 1 of this piecewise function. Now, since 1 is the border value between these rules, we have to look at the left and the right-sided limit. So for the left-sided limit at 1, we're using this less than 1 rule. So we can write this as 1 over 2 minus 7 over 2. This comes out to -6 halves, which is -3. Next, we check out the right-sided limit as x approaches 1. So that has to use this rule with x greater than 1 inputs. So we're doing 1 minus 5, which comes out to -4. Now, this is close, but not quite the same thing. Since the left and the right-sided limits don't match, that means our two-sided limit at 1 does not exist. For this problem, we're trying to find the limit as x approaches 4 of this piecewise function. Since 4 is the border value for this, we're going to find the left and the right-sided limits just to make sure they match up. So taking the left-sided limit at 4, that's going to be using this first rule with values less than 4. So we have 4 over 2 minus 5, and that's going to come out to 2 minus 5, or -3. Next, we take the right-sided limit of 4. That uses this greater than 4 rule. So we have negative 2 times 4 plus 5. That's negative 8 plus 5, which is also negative 3. Since the left and the right-sided limits agree, then the two-sided limit is going to be whatever they agreed on, which was negative 3. On this problem, we're trying to figure out the limit as x approaches negative 2 of this weird-looking absolute value fraction function. So I'm going to start by representing this whole thing here as f of x, just so I can quickly refer to it. And it turns out because this is absolute value, there's kind of a built-in piecewise function going on that I'm going to rewrite this as. So piecewise function, we've got a border value. The border value here is going to be the place where the stuff inside absolute value starts being negative or starts being positive, whichever. So we have to find out what zeroes out the absolute value, because that's where we're changing signs. So if I plug in negative 2 here, negative 2 would be positive 2, minus 2 would give us 0. So I'm going to have two rules in my piecewise function. One for x values less than negative 2, one for x values greater than negative 2. And I can't have one for exactly negative 2 because that would give me 0 in the denominator, so that wouldn't exist anyway. All right, so if x is less than negative 2, well, let's see what happens in here. So let's say I take something easy like negative 3. Negative 3 would be positive 3, minus 2. That would give us a positive number inside. So if I'm getting numbers that are positive already in here, I don't really need the absolute values positivity feature at all. I can just rewrite this as 5 parentheses negative x minus 2 over negative x minus 2 without any absolute value, because I don't really need absolute value. Now let's say we have values of x that are greater than negative 2, like for example 0. Well, 0 minus negative 2 would give us a negative number, then we would need absolute value to make the output positive. So for numbers greater than negative 2, I'm going to negate this whole thing here. So let's see here. I'm going to have like a negative inside on both of these, but I'm actually going to factor that out. So I'm going to write this as negative 5 parentheses negative x minus 2. What's really going on is I made everything inside here opposite sign, and then I immediately factored out a negative 1. Now the reason I did that, you're going to see that in just a second. It's going to make my next step a little bit more manageable. Because if you just try to take the left and the right-sided limits using these rules, you're going to run into a problem, because you're going to try to plug in negative 2 to these rules, and you're just going to get 0 over 0. So we actually have to simplify these a little bit before we try doing that. This top rule here, I can cancel out a negative x minus 2. That leaves me with just 5 up here. With this bottom rule, I do the same thing, and it leaves me with negative 5. So I can rewrite this as 5 for x values less than negative 2 and negative 5 for x values greater than negative 2. At this point, I just have to look at the left and the right-sided limits, because negative 2 is the border value here, as it turns out. My left side limit for x values less than negative 2, I'm going to get 5 if I evaluate that. Right-sided limit at negative 2 is using the second rule, giving me negative 5. Since these two don't agree, the two-sided limit does not exist, after all that. On this problem, I'm trying to find the right-sided limit as x approaches negative 1. So to make my life a little bit easier here, I'm going to express this whole thing as f of x, just so I can quickly refer to it without rewriting it. And then, since this has this absolute value here, this is actually a piecewise function, so I'm going to rewrite this using two different rules. The rules are going to switch whenever the stuff inside absolute value is 0, because at that point, we're changing from negative stuff to positive stuff, which means the absolute value has to do different things. So the thing that's going to turn this absolute value expression into 0, that would be negative 1. Negative 1 minus 1 would give me 0. So I need two rules, one for x values that are less than negative 1, one for x values that are greater than negative 1. And if x is exactly negative 1, which I didn't include anywhere here, well, then that would give us 0 in the denominator, so that wouldn't really help us out anyway. So for x values less than negative 1, let's try one out, like negative 2. Negative 2 would be positive 2, minus 1 would give us a positive number. If the stuff inside absolute value is coming out positive anyway, absolute value doesn't really need to do anything at all. It doesn't even really need to be there. So for this rule, we're just going to rewrite this, but we're going to replace the absolute value with, well, nothing. You could have a parentheses there if you wanted, but really nothing is happening. For this next rule, though, x value is greater than -1. Let's try one of those out, like 0. That would give me 0 minus 1, which is a negative number. And if absolute value has a negative result inside, then it has to multiply everything inside there by -1 to force it to be positive. So I can rewrite this as, well, I guess I could rewrite it as x plus 1 inside if I just negate everything. But I'm going to be kind of sneaky and take a negative out of there. So basically factoring a -1 out of those two terms to get rid of the absolute value. And you're going to see why I did this in just a sec, but believe it or not, this is actually going to help us out a lot more than having x plus 1 in there. All right, so for my next step, I would consider trying to plug in -1 to both of these to find the left or right side limits. The problem is both of these are going to give you 0 over 0 the way they are. So we need to factor and cancel out common factors before we can go anywhere else in this problem. Now, as luck would have it, we can take a 2 out of the numerator, leaving us with a -x minus 1 inside, and we can do the same thing in this numerator. So we can take a 2 out in both of those numerators. For the top rule here, the -x minus 1s are going to cancel, so that's just 2 for that rule. Pretty much the same thing on this bottom rule, except we have a negative outside as well, so that becomes -2. And at the end of this one, we just wanted to find the limit as x approaches -1 from the right side. So that's going to use this second rule here for x values greater than -1, and that ends up being -2. So that's going to be it for this one. On this problem, we're defining f as this crazy-looking piecewise function, and we want the limit as x approaches 0 of this thing. Now, this is a little bit wild because absolute value is itself a piecewise function, so we have essentially a piecewise function inside a piecewise function. Well, I'm just going to rewrite this as another piecewise function. For this piecewise function, we're actually going to have 3 rules. We've got this absolute value is actually getting split up into 2 rules. We have a rule for what happens if x is less than 0, and we have a rule for, so that's going to be x over -x, because if x is less than 0, then I have to force the stuff inside here to be positive. So that's the rule for x less than 0. We have 0 if x is exactly 0, and then we have a rule for what happens if x is greater than 0. If x is greater than 0, then I don't really need the absolute value at all, so I'm just going to write this as x over x for x greater than 0. And of course I can simplify this a little bit. Like this up here is really -1. This third rule is really +1. And so now to find the limit as x approaches 0, I need to consider the left and the right-sided limits. So the left-sided limit, that's going to be this one right up here. That's going to be -1. The right-sided limit, we're going to use the values for x greater than 0. That's going to be +1. Since those don't actually match up, that means the two-sided limit that they're asking for does not exist, so that would be choice D.